bring your own lunch.
Yeah, next to the Tom and
No.
Cody, and they just take on the
So
fries.
I do.
You taking fries?
I do.
Tyler got a 33 on his ACT.
I heard about that.
Yeah, everybody
Probably
had
before I did.
I saw it on Facebook. Yeah.
Before I heard about it.
Yeah, I had to go home and get money. Did you put me down for a meal? Because I paid Miss Barrington my money.
Probably.
I have no idea.
That's not encouraging.
Would-
I'm gonna be
did you
real
give her- did you
salty
give
if
her-
everybody's eating barbecue in front of me on Monday.
Did you give her the money after we came in here?
Yes.
Then she probably pushed in.
Okay.
We gave her all the crap. So.
Okay. All right.
So,
Because
I
if I don't have barbecue Monday, I'm gonna find you
I
two.
washed my hands from it because she had it.
Okay. Anyway, I had to go home and get the check, and so while I was at the house, I got on Facebook because what else do you do? And like right there, there's your mom bragging on your ACT. So.
Pretty sure she did that before she told me.
Yeah, because Tyler pulls out his phone. He's like, "Hey, I got a 33 on the ACT. Cool." And then like 10 minutes later, we're walking through the middle school and people were like stopping him and saying stuff.
That's great.
It was weird.
That's fantastic. What was your math?
I think it was 27.
It's pretty good. It's pretty good. When you finish pre-cal, you're gonna kill it. Okay, so here's the plan. We will be in class today, and pretty much this is different from the other algebra 2. So I need you to know that the other algebra 2s are mostly done because they're juniors and I won't see them again. I will see you next week. Like, you don't have a trip on Tuesday. You don't take AP exams 2 days out of the week next week. I will see you next week. Okay. So you are not done. If you hear from another class, if you hear from an 11th grader, oh, she told us we're done. You're not done. You're 10th graders. Okay. Except for you, which we'll do what we need to do because I know you're going to miss Tuesday. You're not done. Okay.
We're gonna have another test.
We will try to fit in. This is our last section. So we're going to try and fit in the quiz next week. We'll do the quiz. And then Thursday, we'll start reviewing for the semester test because some people in this class have to take the semester test. And your semester test is Monday.
You know those people.
Not like 3 days from now Monday, but the next Monday. I will know on Monday. So I will have a list of who has to take the semester test. Put your chair down on Monday. Okay, so one more time. 10th grade. Y'all are not done. You have another quiz. Okay? The other two classes, if they're like, well, she said we're done. That's great. They are. I won't see them next week, but maybe one day, and that's Thursday. So you are not done. All right. You're not going on the trip? Okay. All right. Okay, let's look at graphical properties of polynomial functions. Are you in AP Lang? Okay, so you will be here. Okay. All right, so we've got three functions, f of x, g of x, and h of x. F of x is a cubic function, which means at some point its highest degree was x to the third. G of x was a quartic function, which means at some point its highest degree was x to the fourth. And then h of x is a quintic, which means at some point it was x to the fifth. Now, it could have been like 2x to the fifth, 9x to the fifth. It probably had other stuff after that. But the highest power of x was x to the fifth, okay? Left end behavior and right end behavior. I think that we've talked about end behavior for a second, but end behavior is what's happening on the end of a graph. You're like, they don't end. I know. It's really just like what's happening on the left side, what's happening on the right side. For left end behavior, x is going to negative infinity. That's what's happening on the left side. But that's just indicating that you're looking at left end behavior. That's not actually the end behavior, because the end behavior is the graph itself. So you say, okay, as x goes to negative infinity, what's happening to f of x? It is going to negative infinity. So you got two choices, positive infinity or negative infinity. You got two choices right now. Later, you will have other choices. today you have two choices: negative infinity or positive infinity. Okay? It's not terrifying. I promise it's not. If it goes up, that's positive infinity because numbers get bigger as you go up. If it goes down, that's negative infinity because numbers get smaller as you go down. Okay? Now, the right side is indicated by saying that x is going off to infinity. As x goes off to infinity, because when you go to the right, you're going to positive infinity. On this particular graph, what's happening as x goes off to infinity? What's f of x doing? It's going off to infinity. See, it goes up, it's getting bigger, it's going off to infinity. What are the zeros of this particular graph?
-2, -1.
Okay, so x equals -2, x equals -1, x equals 1. Those are the zeros. X equals, make sure you have the x equals on there. Guaranteed factors. Okay, so if I have a 0 at x equals -2, what is a guaranteed factor? X plus 2. What's another one? X plus 1. And the last one? X minus 1. Okay, see if you can do the quartic function. Answer the questions for the quartic function without me. And then I will jump in as needed. All right, so what's happening on the left side? What's happening as x goes off to negative infinity? What is g of x doing? All right. And as x is going off to positive infinity on the right side, what's g of x doing? Yeah. What were your zeros?
-5, -2, 0, and 2.
So your guaranteed factors would be
X plus 5, x plus 2, x minus 2.
yes. Okay, work on h of x. Do your quintic. What's happening on the left side of the graph?
As x approaches negative infinity, h of x approaches negative infinity.
All right, what happens on the right side?
As x approaches infinity, h of x approaches infinity.
Yep. And your zeros are at x equals -4.
-2, 2, 2, 5.
I'm only gonna write one of the twos because they're not space. All right, so that's going to be factors at x plus 4, x plus 2, x minus 2 a couple of times, and x minus 5. So we talked a little bit about multiplicity already, but we haven't actually defined it. I just sort of told you about it. But it's just the number of times that x is a zero of a function. We actually see this lesson again at the beginning of pre-cal next year, and we spend a lot more time on it than we're going to for Algebra 2. Algebra 2 is like a little taste of it. And then pre-cal is like the whole dish. I know, it's awesome. All right, so let's talk about multiplicities. For f of x, all the zeros have a multiplicity of 1. For g of x, all the zeros have a multiplicity of 1. For h of x, -4, -2, and 5 have a multiplicity of 1. X equals 2 has a multiplicity of 2. And what's different about x equals 2? As opposed to all these that have a multiplicity of 1?
It occurs twice.
Yeah. What's different on the graph?
The curve is such.
Right. It's just, it bounces. It's tangent to the graph. And it touches it and then comes, it doesn't go through it. It just touches it and comes back down. It's like it ricochets. Okay. So the behavior of the graph as it approaches 0, when it has a multiplicity of 2, it approaches it, it touches it, and then it goes back away from it. It doesn't pass through it. It just bounces and then it goes. All right, page 503. All right, so we're looking at degrees, the lead coefficient, and then in behavior, if it rises or falls. So, like number 1, the highest power is 2, so that's an even degree. And the lead coefficient is 2, so that is positive. Number 2, the highest power is 4, so that's even. Lead coefficient is -1, so that's negative. Okay. See what to do in the first 2 columns? Yes? All right, take off. All right, do you have the first 2 columns done? Yes, no, maybe? Okay, now let's start graphing them. I think there's a couple people still writing in their chart, so hang on a second. I'll tell you what, I'll go ahead and get on Desmos, and then love Desmos. One of my most favorite. Okay, can I get this? All right, so number 1 is 2x squared minus 3x plus 3. Okay, so is it rising or falling on the left side?
Rise.
Rise. Is it rising or falling on the right side? Rise. Okay, so R and R. R and R. I know you're all thinking it. So okay, look at number 2. I have what? A negative x to the 4th plus x to the third. Minus x squared. Plus 3.
Yes.
Okay, so what's happening on that one?
Fall.
Fall and fall. Oops, I grabbed the wrong pen. It's a different color. That's okay. What's gonna happen on number 3? I feel like we're familiar enough with quadratics. You should be able to tell me what's gonna happen on number 3 without me graphing it. It's gonna fall and fall. All right, it is. Let's look at number 4. I can take out that negative. What's gonna happen as soon as I take out that negative?
Right.
Yeah, it is.
That was weird.
So that's gonna be R and R
Making that shape.
because it has some weird zeros in it. And number 5 is an x to the third. X to the third minus 3x squared. Plus 2x. Minus. What's happening with that one? Fall and then rise. What would happen if it was like number 7 with a negative right there?
Rise, fall.
Rise and fall. That's number 7. All right, let's do the 5th. Number 6 that I kind of skipped. X to the 5th. What's it gonna do?
Fall and rise, I'm guessing.
Fall and rise. Yeah. Do we kind of see a pattern here? All right, what's gonna happen to the end behavior of functions that have an even degree? What's gonna happen with their end behavior?
Be the same.
Yeah, they're gonna have this. They're gonna have matching end behavior. They go the same direction. It's either going to be like this. When is it like that? When it's positive, or it's going to be like this when it's a negative lead coefficient, right? Okay, what about in behavior of functions that have an odd degree? They go opposite directions, okay? So which one will start low and end high?
Positive.
That's a positive lead coefficient, and a negative lead coefficient will start high and end low. Can I flip, or are we still writing? All right. More specific conclusions can be made looking at the degree of the function combination lead coefficient. We just did that, but we're going to actually write it out like normal, okay? So let's do an even positive first. The left end behavior would be as x goes to negative infinity, f of x goes to what? Not an even positive.
Wait, no.
Infinity. And the right end behavior as x goes off to infinity, what's f of x doing? Going to infinity because they have matching end behavior. So if it's an even positive, they're both going up. Looks like this. I am an even function right now. Okay. What about an even negative? As x goes to negative infinity, what's f of x doing? Negative infinity. And as x goes to positive infinity, what is f of x doing? negative infinity. They have matching in behavior. And if it's negative, they go down. Since I accidentally changed colors anyway. See, I'm going to change colors on purpose now. If I can find another color. I'm going to do the odds in a different color. Or not, because I can't find one. It's just another pink. Odd, positive. As x is going to negative infinity, what's happening to an odd positive?
Negative.
Yes. For an odd positive, what's the right in behavior? As x is going off to infinity, what is f of x doing?
Infinity.
Infinity. What about an odd negative? What's the left side look like?
Negative. Oh, wait, positive.
Positive.
Positive infinity. On the right side,
Negative.
negative infinity. Yes. Oh, there's one. Green. All right, give an analytical example of a function whose in behavior, a cubic function, my bad, a cubic function whose in behavior is such that as x goes to negative infinity, g of x goes to positive infinity. Okay, what's a cubic function that would have that in behavior?
X cubed.
X cubed plus x squared plus x plus whatever.
Would just plain old x cubed have that in behavior? Would it be going up on the left side? That's the left side. Should be a negative x cubed, right? And then you can put whatever you want after. It doesn't really matter. Minus 11,000. It's specifically, that is the exact answer. I'm just kidding. It's not the exact answer. Okay. So why is this? It's cubic because the highest degree is cubic. Highest degree is 3. And then how do I know that that has matching in behavior? Because the lead coefficient is negative. In behavior matches because the lead coefficient is negative. Okay, draw the graph of a quartic function that has a 0 of multiplicity of 2 at x equals negative 3, roots at x equals 0, x equals 2, and a right in behavior such that as x approaches infinity, g of x approaches infinity. Okay, so it has a 0 with a multiplicity of 2 at x equals negative 3. So what's going to happen there? Yeah, it's just going to touch it and bounce off, okay? What's going to happen at x equals 0 and x equals 2? It's going to go through it. And does this open up or does it open down? How do you know?
Positive.
The right side says it has positive and they have matching in behavior. So there. Where's the other one? 2? Okay. So I have to bounce, pass through, and go out. So it's tangent at x equals negative 3, and it crosses through at x equals 0 and x equals 2. Give an example of a quartic function whose in behavior is such that as x approaches negative infinity, g of x approaches negative infinity. What would that look like?
Negative x to the fourth.
What?
Negative x to the fourth.
Negative x to the fourth. Yes. It's quartic because the highest degree is 4. And the left is falling because the lead coefficient is negative. Got it. Page 505. All right, identify the zeros and their multiplicities. Okay, so what are the zeros on this first one?
Negative 2, 1, and
What are their multiplicities?
3. 1.
1, 1, 1.
What's the degree and type? It has 3
Cubic.
zeros and none of them repeat, so it is a 3rd degree cubic. Okay, last one. Determine if the leading coefficient of the equation is positive or negative and justify your conclusion. Then write a possible equation for the function. Okay, so is the lead coefficient positive or negative?
Positive
How do you know?
because it goes from, it rises.
Okay, because as x approaches negative infinity, f of x is approaching negative infinity. As x approaches positive infinity, f of x is approaching positive infinity. All your zeros and their multiplicities have to add up to what your degree is, okay? So what's my possible function here? What are your zeros?
Negative 2, 1, and 3.
Okay, turn them into factors.
X plus 2. X minus 1.
Mm-hmm,
X minus 3.
perfect. Perfecto. What are your zeros on this one?
Negative 2 and 1.
Negative 2, negative 2, 1, 1.
Okay, so that has a multiplicity of 2 and that has a multiplicity of 2.
Oh,
Mm-hmm. And then what's the degree?
2.
No,
4.
4. And it is a quartic
Why do they have multiplicities of 2?
because it bounces. It doesn't pass through.
So it occurs twice.
Yeah. Go ahead and finish that one. Yes, ma'am.
I was gonna give this to them. Can I go ahead and give this to you?
Yeah. 'cause we're
They
gonna
said
go
they
back to
did
the-
not write my name down.
I don't know
Okay.
where in elementary we're supposed to go.
All
No, I mean, Miss McCann told us to meet her.
door to door.
Well, I think we're gonna be in the
She
auditorium.
just told us that she'd be over there if we needed her.
Oh, okay, I was gonna say, just ask the teachers, and I wrote Miss Harper's name down.
Begging for money. I'm glad someone wrote my name down because I really want barbecue. So is the lead coefficient positive or negative? Negative because why?
Going down both ways.
Yep, as x approaches negative infinity, what's f of x doing? And as x approaches positive infinity, f of x approaches positive infinity. And what's your possible equation? How about x plus 2 squared and x minus 1 squared? Is that done? Where's your negative? You said it was a negative.
Negative 1.
Right there. You need that. You need that negative.
People are screaming.
What? Next door? Yeah, it happens a lot.
Okay.
It's okay. It's okay. It's okay. All right, try to do this one without me. All the way across. Lad, you're being checked out and you need to call Miss Gibson on her cell phone, but I don't know if she means right now or after class. So I just asked her. I guess you're going to the game with them? I don't know. But you've got 5 minutes, so right now, yes. So get out. Be gone with you. By the way, you need to try and do day 62 before you come back on Monday.
Do homework 62?
Yeah. Not the free responses, just the pages. Yeah. Okay, so what are the zeros here?
-2 and 1.
-2 and 1. Any multiplicities?
1 and 2.
1 and 2. And it is a cubic with 3 degrees. Positive or negatively coefficient?
Negative.
Negative because
As x approaches negative infinity, f of x approaches infinity, and as x approaches infinity, f of x approaches negative infinity.
right. And f of x equals what?
Negative x plus 2, x minus 1 squared.
Yeah.
Okay.
Good. All right. Fantastic. Let's look at the graphs on the other side. Sketch a possible graph. Okay. Well, like if I wanted to sketch a graph of this, I'm going to have zeros where?
-2, 1, and 3.
Is it going to pass through these zeros?
It passed through.
Yes.
It's going to pass through all of them because there are no multiplicities, right?
Yes.
Okay. What about in behavior?
That's positive.
Okay. It's positive cube, so it's going to be here, here, and here. That's it. You just have to sketch a possible graph. That's all you have to do. What's different about that one and g of x?
There's a
no
multiplicity.
Okay, where is it?
Negative
-1,
one.
Negative
and then I have a 0 at 2. So this one would go up to -1, but then come back down before it goes out. How about, let's do like the ugliest looking one. Probably p of x. Pretty gross. What's that going to look like?
Gonna pass through -3.
It's going to pass through -3. Okay.
And bounce off of 2.
So it passes through -3. It's positive, so it's going to be like that. Bounce. Bounce. Okay. It's not bad. That wasn't as bad as I thought. What about that one?
That's gonna be negative.
Yeah.
It's gonna pass through -2 and 3, and it's gonna bounce off of
Pass through -2 and pass through 3. Oh, okay, I see. Okay, yeah, sorry. And bounce at 1. Is it up or down?
down.
All right, so it's gonna be. It's kind of like arches. McDonald's. Perfect. All right, so day 62 homework is really just more like an extension of your notes. Okay, it's asking you a lot of questions about the notes. You do not have to do the 4 free responses. You just have to answer these questions. And it seems like a lot, like there's 16 of them, but it's really 5 problems, I think, 4 problems, because it asks you questions about the same graph over and over again. So it shouldn't take you very long at all. You probably find time in your classes today to finish it, so you don't have to accidentally forget and do it Sunday night or Monday morning before you come in.
Right. I did it a lot.
Y'all have a great day, good weekend, make good choices.